Okay, so what we're doing on this assignment is we're trying to solve and get the trig function by itself first, so that we get, like, for example, on number 1, we want to get sine theta equals some number. Then we want to state basically all the angles that theta could be that give us that particular sine or y value. So first thing we need to do is we need to solve to get sine by itself. So we solve these equations just like we would any other algebra problem, but we were wanting the sine part by itself. This is kind of like our variable that we're solving for here. So we want to get rid of the minus 1 first by adding 1. So we have 2 sine theta equals 1. And we still want sine by itself, so we divide both sides by 2. So we get sine theta equals 1/2. Now we want to state all the angles that we have sine values equal to 1/2. And we got to remember that sine is our y value. So if we go and we're looking for basically where do we have y values equal to positive 1/2. So if we look at our unit circle, here's one at pi over 6, and here's one at 5 pi over 6. So those are our two answers. Okay, number 2, we're doing the same thing. We're solving now. We want to get secant by itself. So we're going to solve. So we need to get rid of the minus first by adding it. So we have the square root of 3 times secant theta equals 2. So now we want to divide both sides by square root of 3. So we get secant theta equals 2 over the square root of 3. Now secant is not on our unit circle, but if we remember, secant is the reciprocal of cosine. So what we can do is we can flip this fraction and rewrite it as cosine. So we're looking at where do we have cosine, and remember cosine is our x values. So where do we have x values equal to the square root of 3 over 2? And we're going to state those angles. So we have an x value of square root of 3 over 2 here at pi over 6, and we have another one down here at 11 pi over 6. So those are our two answers. Okay, number 3, we're going to work it similar to how we did number 2. This time though we have secant squared, so we have one extra little step when we solve. So we still want to get rid of the plus or minus first, so we're going to add 4. So we have 3 secant squared x equals 4. And now we want to divide both sides by 3. So we get secant squared x equals 4/3. And in order for us to use our unit circle, we have to have just the trig function, so we need to get rid of the squared by square rooting both sides. So on this side, we're going to be left with secant. And when we take the square root of both sides, we got to put a plus and minus. So when we square root fractions, we square root the top and we square root the bottom. Square root of 4 is 2. Square root of 3 is irrational, so we leave it as the square root of 3. Now, just like the last one, secant is not on our unit circle, so we got to flip it to become our reciprocal, which is cosine. So the cosine is equal to plus or minus, and we flip the fraction. So cosine, again, we're looking for x values. So we're looking for where do we have x values equal to positive or negative square root of 3 over 2. So if we look at our unit circle, we have one here at pi over 6. Here it's negative square root of 3 over 2 at 5 pi over 6, 7 pi over 6, and 11 pi over 6. So those are all 4 of our answers. Okay, number 4, we're doing pretty much the same thing we did on number 3. It's going to be very similar, except for we're not going to have to flip it, because cosine is actually on our unit circle. So we want to get rid of the minus 1 by adding it, just like any other algebra problem. 4 cosine squared x equals 1. Now we want to get our cosine part by itself, so we're going to divide both sides by 4. So we have cosine squared x equals 1/4. Now we can't find cosine squared on our unit circle. We need it to be just cosine. So we got to take the square root of both sides. So on the left, we're left with cosine of x. And since we took the square root of both sides, we need a plus and minus. And we can take the square root of the numerator, which is 1, and the square root of the denominator is 2. So we're looking for where do we have x values equal to positive or negative 1/2. So that happens here, pi over 3. Here's the negative 1/2 at 2 pi over 3. And notice the colors are all the same. So here 4 pi over 3 and 5 pi over 3. So those are our answers. Okay, so here's our first one with tangent. Now when we do it, so we're going to solve these the same way. We want to get the tangent of x part by itself first. So we need to get rid of this plus square root of 3. So we're going to subtract the square root of 3. We have the tangent of x equals the negative square root of 3. So on these, we can use our unit circle. Because we already have the tangent values written on there, so we're looking at basically where do we have tangent of theta equal to negative square root of 3. So here's the positive one, so here's the negative one, so that happens at 2 pi over 3. And the other one happens over here in quadrant 4 at 5 pi over 3. So those are our answers. Okay, number 6, we're going to try to be solving for cosecant squared here. So we want to get this cosecant squared by itself, so we've got to get rid of the minus 2 by adding it. So we get cosecant squared x equals 2. Now we can't have any square trig function, so we need to square root both sides. So we get cosecant x on this side, and when we square root both sides, we have to put a plus and minus, and then the square root of 2. Now on this one, cosecant is not on our unit circle, but its reciprocal sign is. So if we think about this as the square root of 2 over 1, and we find the reciprocal of that, we get 1 over the square root of 2. Now this we need to rationalize because we can't have the square root in our denominator, so we're going to have to do one extra step before we can actually look at our unit circle. So we didn't do anything to this side. Keep the plus and minus. So 1 times the square root of 2 is square root of 2. Square root of 2 times square root of 2 is 2. So we're looking for sine. We're looking at the y value. So where do we have y values equal to positive or negative square root of 2 over 2? So that happens here at 45 degrees or pi over 4. Here at 3 pi over 4. Here's the negative at 5 pi over 4, and here's the other negative at 7 pi over 4. So those are our 4 answers. Okay, now number 7 needs to be worked just a little bit differently. What we want to, since we have cosines on both sides, we want to get all of the cosines on the same side. And the reason why we want to do that is we're going to end up having to factor on this one. So I'm going to move this cosine over to this side by subtracting cosine of theta from both sides. So those go away to become 0. And over here we have cosine cubed minus cosine theta, and that all equals 0. Now notice that we have a cubed and cosine. So we can't subtract these to say cosine squared because the powers are different. So what we're going to have to do on this one is we got to look at what do both terms have in common. These both have a cosine, so we can factor that out. We'll be left with cosine squared theta minus 1. Now on this one requires a little bit more work. So we do need to basically take each of these factors and set them each equal to 0. So we're going to take cosine of theta, set it equal to 0. And we're also going to take cosine squared theta minus 1 and set that equal to 0. So what we're doing is we're basically looking for x values that equal 0 for this one because it's already solved. So x values equal to 0. So that happens here at 3 pi over 2, and it happens here at pi over 2. Now we're also going to have to solve this other equation over here, so we need to add 1. We get cosine squared theta equals 1, and then we got to take the square root of both sides. So we get cosine theta equals plus or minus 1. So we're also looking for where do we have x values equal to positive 1 or negative 1. So we have a positive 1 here at 0, or you could say 2 pi. And we also have a negative 1 here at pi. So those are going to be our answers. 0, pi, and you can also include 2 pi.